Hello my dear children, welcome to my channel Sudhir Sir Chemistry. Today I am going to take a second part of the chemical bonding where we are going to learn a very shortcut methods as well as a tricks to understand or how to draw the molecular structure. In yesterday's or in the previous topic, we can say in the previous video I have given about the explanation of introduction part of the chemical bonding. Chemical bonding is the kind of the bond, the types of the bond. Types of the bond is nothing but the force of attraction that existed either between the atoms or in between the molecules. The force of attraction which existed between the atoms are called as an interatomic force of attraction, and the force of attraction which existed between the molecules are called as a intermolecular force of attraction. This interatomic force of attraction can be written as an interatomic bond, and intermolecular force of attraction is also written in the form of intermolecular bond. So this interatomic force of attraction is of following type: ionic bond, covalent bond, coordinate bond. And intermolecular force of attraction is of 5 types, which was already explained in the states of matter. But anyhow, when I will take the method or I will take the part of the states of matter, there I will give the explanation of all the 5 types of the intermolecular force of attraction. That is ion dipole interaction, dipole dipole interaction, dipole induced dipole and induced dipole, which is also called as a London dispersion force, and the last one is hydrogen bonding. So that is the yesterday part I have explained you. In yesterday part again I have given the explanation about the stability of the atoms or the stability of the molecules. This stability of the atoms or the molecule can be given by two concepts. Old concept, octet rule. New concept, lower the energy, greater the stability. So both explanation was over in my previous video. Today I am going to explain about the structures of the molecule. In this particular part, that is about in the chemical bonding, we are going to learn how to draw the structure of the molecule, or we can say the molecular structures. So I should write how to draw the structure of molecules. To know the structure of molecules, to know the shape of the molecule, what we require here two concepts. The first concept will be called as a Lewis dot structure. How to draw the Lewis dot structure of any molecule, as well as how to draw or how to write or what we mean by the octet rule or octet configuration. If you know both these two particular topics, that is a Lewis dot structure and octet rule, then we are able to draw the structure of molecules. In this Lewis dot structure, we are going to learn about the example. I want to tell you hydrogen atom. Then we'll tell about the hydrogen. Next to hydrogen, go for the helium. Then for the lithium. Then it will come for the beryllium. Lithium. Then it will come for the beryllium. Then it will come for the boron, carbon, nitrogen, and all. For writing this Lewis structure of this particular atom, just we should know the configurations. Let us say, first of all, the part I am going to explain you Lewis dot structure. Let us say, for writing the Lewis dot structure of hydrogen atom, we should know its atomic number is 1. So configuration should be 1s1. Number of electron in the valence shell is 1. That means hydrogen has only 1 electron, means 1 dot. In the same way, helium, atomic number of helium is 2. Configuration can be written in the form of 1s2. That means number of electrons in the valence shell of helium is how many? 2. So we should write this 2. Means it is a way to write here. Or we can say these are the two, we can say having these two particular atoms in this way, helium. Second one, go for the lithium. Atomic number of lithium is equal to 3. That means configuration come in the form of 1s2, 2s1. You can see this is a valence shell of lithium, and in this valence shell only one electron, atomic number 3, only one electron in the valence shell. So lithium has only one electron in the valence shell, so can be written in the form of 1 dot. Then go with a beryllium, Z is equal to 4. Then with a boron, Z is equal to 5. Then with a carbon, Z is equal to 6. For beryllium, Z is equal to 4. We know the configuration of beryllium: 1s2, 2s2. Boron, 1s2, 2s2, 2p1. Carbon, 1s2, 2s2, 2p2. In beryllium, valence shell is 2s. Number of electrons in the valence shell is 2. So beryllium will having a 2 electrons can be written as 2 dot. Now the people are getting the doubts, sir, why we wrote the 2 this different dot here and both the dot here. So that part I am going to explain you about the octet rule. Here boron, valence shell 2s and 2p. Number of electron present in the valence shell, how many? 2 plus 1, 3. So boron is having 3 electron, 1, 2 and 3. Why we are writing these 3 electron differently? Because they will have a repulsion, and to minimize the repulsion these electrons should be far away from each other. Go for the carbon. In valence shell, total electron present in the valence shell is 4. Carbon 1 dot, 2 dot, 3 dot, 4 dot. In such a way we are able to draw the Lewis dot structure for all the element present in the periodic table. So these are the things required. Which one required I have given here. Few more examples are here. Let us see the nitrogen. Z is equal to 7. Configuration will come in the form of 1s2, 2s2 and it becomes 2p3. Total number of electron in the valence shell is 3 plus 2, 5. That means this 5 electron in the nitrogen can be written in this way, 3 plus 2, 5. Actually we can write in this way also, or 1, 2, 3, 4 and 5. This way also we can write, both the way for nitrogen. In the same way oxygen. Atomic number of oxygen is 8. Configuration will come in the form of 1s2, 2s2, 2p4. In valence shell, 4 plus 2, 6 electrons are there in oxygen atom. 1, 2, 3, 4, 5 and 6. You can check it. These are the 2 paid electron and these are the 2 unpaid electron for the oxygen. It can be written in this way or it can be written in this way. So these are the Lewis dot structure of oxygen. So for writing the structure of any molecule, the concept which one we require, Lewis dot structure and octet rule. How to draw the Lewis dot structure and how to write the octet rule. So Lewis dot structure, how to draw, that is some examples I have given for you. Now let us check with the octet rule. Please, if possible, please note down this one because I am going to explain the second part of that one, octet rule, and combining of these two together will help us to draw out the structure of any molecule. So now the second part I am going to explain you about octet rule. Octet rule. According to this octet rule, what is that? The atoms should have 8 electrons in its valence shell. If the atoms are having 8 electrons in its valence shell, that particular atom become or the ion becomes stable. Except for hydrogen and for helium, which should have only 2 electrons in its valence shell. The atom or the ion which is having 2 electrons in its valence shell are called as a duplet configuration. That can be shown by only hydrogen and helium. But atoms or the ions having 8 electrons in its valence shell having the stable configuration, and it will be called as a what? That will be called as a octet configuration. So these are the two things we should remember. That should have a octet and someone should have a duplet. Duplet can be shown only by the hydrogen and the helium. It will get the stability. But other than that, the remaining all atoms are having a octet configuration to attain the stability. For this one, attaining the stability by having the 8 electron in valence shell, the atom can either lose electron or can gain electron. By losing or by gaining, it can get the positive or by the negative charges. That will be called as a cation as well as a anion. Now I am going to explain about the structure of molecule, how to draw and how to determine the structure of molecule with the help of Lewis dot concept, Lewis dot structure as well as with the octet rule. So now I am going to explain a few examples for drawing the structure of molecule. Let us go with some examples here. Example number 1, hydrogen molecule, H2 molecule. First of all, we should know the structure of this hydrogen atom and another hydrogen atom. You can check it here. Hydrogen atom is having only 1 electron in the valence shell. It is also having the 1 electron in its valence shell. This hydrogen atom can share its electron from here and will have a duplet configuration. This hydrogen atom can also share its electron from this hydrogen and can attain the duplet configuration. By sharing, it will form the bond. The bond will be called as a what? Covalent bond. Means we can say in between these two atoms, the bond formed here, the bond is called as a covalent bond because it is a bond formed by sharing of electron. It is one example of hydrogen molecule. Check it with some more examples here. Let us say I want to go with the example of HCl as well as with the N2 molecule. Now, second example. Let us say the second example is HCl. Lewis dot structure of hydrogen, this one. Lewis dot structure of chlorine, 1, 2, 3, 4, 5, 6 and 7. Now Chlorine is having a octet configuration 2 4 6 7. So this chlorine is sharing its one electron with a hydrogen, and it will have total how many? 8 electron. In the same way, this hydrogen also sharing its one electron with a chlorine and will have duplet configuration. So by sharing the bond present between hydrogen and chlorine, the bond is called as a covalent bond, because the bond formed due to sharing of electrons. Let us check with the example number 3 now. That is with the nitrogen molecule, N2 molecule. For writing these structures, the concept will be first Lewis dot structure. According to Lewis dot concept, this nitrogen is having a 3 electrons and plus 2 5 electrons. Other nitrogen should have the same thing, that is 3 electrons and 2 electrons. Now to getting the octet configuration, it is sharing these electrons together, and you can check it here. This nitrogen is having total of how many? 2 4 6 plus 2 8, and this other nitrogen also having how many? That is 2 4 6 plus 2 8. So by having the octet configuration, they are sharing and form the bond. So now what we can say, in between the nitrogen, it is a triple bonded or triple bond present between the nitrogen. Same thing we can check it with the oxygen molecule, O2 molecule. Oxygen atom 1 2 3 4 5 6. Oxygen atom 1 2 3 4 and 5 6. These oxygen are sharing its electron together and get the octet configuration. Check it here. 2 4 plus 2 6 plus 2 8. This oxygen also 2 4 6 plus 2 8. It also get the octet configuration. That means oxygen double bonded with what? Oxygen one bond is sigma, other bond is what? Pi bond. In the same way, nitrogen molecule is having one bond is sigma and remaining two bond is the pi bond. HCl, that is the only one sigma bond. Hydrogen, that is the only one sigma bond. So it is a way to draw the structure of the molecule. Not only for this one, so we can check it here now. For drawing the structure of molecule, the things which one we required, that Lewis dot structures, as well as the completing the stability by having the octet or by the duplet configuration. Duplet configuration can be shown by either by H2 hydrogen or by the helium. Now we'll go with some more example. That is a chemical bond. That is a type of the bond. Type of the bond or the chemical bond is what? Let us check it here. Now, this chemical bond or chemical bonding is of the following types. Chemical bonding is of the following types. That means the first one will be called as a ionic bond. The second one will be called as a covalent bond. And third one will be called as a coordinate bond. I will tell you in a very simple way. Ionic bond, the bond which is formed due to transfer of electron. Here, the bond which is formed due to sharing of electrons. And third one, coordinate bond, that is a bond which is formed due to sharing of electron, and that sharing of electron can be done by only one atom. Sharing of electron can be done by only one atom. Means one is donor, another one is acceptor. We'll check it about the examples of these all. So these are the type of the chemical bonding that we have to check it here. Now let us say very simple example in this one about the ionic bond, covalent bond and all. We'll see one example based on that one. So first example I want to explain about the ionic bond. The bond which is formed due to sharing of electrons. Let us go with the example of sodium chloride. Sodium atomic number 11, configuration is 2, 1. We can know that KLM. In valence shell, only one electron present with the sodium. Presence of one electron is highly unstable. So sodium atom will loses its one electron, and by losing one electron, it will attain the octet configuration. Now you can check it here. Sodium ion is a stable ion. It loses one electron. Chlorine atomic number 17, configuration 2, 8, 7. That means KLM. In M you can see valence, only 7 electrons are there. So chlorine atom, by gaining one electron, it forms a chloride ion. And now its configuration becomes a stable configuration 2, 8, 8, that is KLM. You can check it here having the 8. Now sodium, which is a positively charged ion, chlorine, which is a negatively charged ion. Actually, in this one, what happened? Transfer of electron from sodium to chlorine. In this one, loss of electron, that is forming a cation, gain of electron, forming an anion. In between these two oppositely charged ion, it is having some kind of force of attraction, and this force of attraction is called as a what? Electrovalent bond. That means why it is called as a electrovalent bond? Because it is a bond present between the two oppositely charged ions, and two oppositely charged ions are having some kind of force of attraction called as electrostatic force of attraction. Hence the bond will be called as a electrovalent bond. It is about the NaCl. In the same way, this NaCl electrovalent bond is also called as a ionic bond because it is a bond formed due to what? Transfer of electron. This metal atom loses electron and non-metal atom gains one electron. So this is a formation of ionic bond can be seen in NaCl. Instead of that, this ionic bond, how it form, where it form, if you want to check it, in that one only one atom should be a metal and another atom should be a non-metal. That means the bond present between a metal and non-metal is nothing but the what? That is called as a ionic bond, electrovalent bond. That is a bond formed between the metal and the non-metal. That is transfer of electron. In this case, transfer of electron will take place from where to where? From metal to the non-metal. By losing positive, by gaining negative, and it will have kind of force of attraction. So that is about the ionic bond. Check it the example of second one, that is a covalent bond. Now second one, that is a covalent bond. Covalent bond is a bond formed between the two atoms by sharing of electron. Means in this one, sharing of electrons takes place, not about the transfer of electrons. Let us go with some example here. Hydrogen molecule. We know that hydrogen having a 1 electron in the valence shell, hydrogen atom having a 1 electron in the valence shell, and by sharing it will form the bond, because by sharing it will have the duplet configuration. By sharing this other hydrogen also have the duplet configuration, and in between these two the bond is called as a covalent bond, and this covalent bond, that is single bond formation, called as a sigma bond. We'll check it about the sigma and pi afterward. Second example, check it here as a O2 molecule. Oxygen atom. First draw the Lewis-Dot structure. Just now I told you, for writing any structure of the molecule, first of all we should know the Lewis-Dot structure and then the octet configuration. Now oxygen atom, you can check it here. It will have the octet configuration by taking these two electrons from the other oxygen atom. 2 plus 2 4 plus 2 6 plus 2 8. So it will form the bond. Same way this other oxygen atom sharing this electron, these two electrons, and forming the octet configuration. In this case, oxygen having a double bonded. One bond is a sigma, other bond is a pi. The first bond formation is a sigma and second bond formation is a pi. Hydrogen, the first bond formation is a sigma. Here, third one, that is about the N2 molecule. You can check it here. I told you Lewis-Dot structure of nitrogen molecule, something like that. Lewis-Dot structure of nitrogen molecule in this way. So they are sharing to each other and form the bond. Now indirectly we can say nitrogen is a triple bonded, where one bond is a sigma and remaining two bonding is a pi bond. Here sigma bond, sigma pi bond, sigma and 2 pi bond, these are the things only by knowing the sharing of the electrons. So these all bonds are what? These all bonds are the covalent bond, covalent bond, covalent bond. Now we can say that these covalent bond is of two types. One is a sigma, other one is a pi. How the sigma form and how the pi form, that part we are going to see in the next topic. But here this is about the covalent bond. Now let us check with the third type of the bond, that is a coordinate bond. And in this one, there already I inform you that is a sharing of electron will be take place. That means sharing of electron can be take place by only one atom. That means one atom is a donor and other atom should be a acceptor. Means condition should be there. One of the atoms should have a excess of electron and other atom should have a vacant orbital for the formation of third type, and that will be called as a coordinate bond. So now let us check with the coordinate bond. Here very simple example of coordinate bond I want to take. That example is nothing but the ammonium ion. Second example we will check it about the hydronium ion, and very extraordinary example we will check it with the SO2 molecule. So let us go with the ammonium ion. The first example, formation of ammonium ion. Formation of ammonium ion. Here ammonia molecule, this is an ammonia molecule. Nitrogen atom is having one lone pair. This is a hydrogen atom whose configuration is 1s1. 1s1 means only one electron in the valence shell. Now by losing one electron, that 1s orbital become a vacant. So just now I told you, for the formation of coordinate bond, it should have a two condition. Condition number one, the species should have a lone pair of electron and the atom or the ion should have a vacant orbital. Now in this case, here nitrogen atom means three hydrogens are there. You can check it here. 1, 2 and 3. This nitrogen completed its octet. That means one bond is equal to 2 electrons. So 2 plus 2 4 plus 2 6 plus 2 8. Hydrogen does not have any electron, so it is unstable. In this case, nitrogen atom will loses its one of the electron to the hydrogen and form the bond. This is the type of a bond formed by this one. It loses, means nitrogen atom is a donor. So arrow will come from nitrogen to hydrogen. Hydrogen atom is an acceptor. By gaining one electron, it will get one negative charge. Positive negative was neutralized. It was cancelled. Nitrogen atom loses one electron. So it will get one positive charge. And here, this molecule can be written in the form of NH, H, H, dative bond plus, or it can be written in the form of what? Ammonium ion. You can check it here. The bond which is formed here, it is a type of a directional bond. It is also called as a dative bond. So it is also called as a coordinate covalent bond. During the formation it look like this way, but after the formation we are unable to differentiate which bond is a coordinate and which bond is a covalent. Means it look like a, means during the formation the bond will become a directional, but after the formation we are unable to isolate which bond is a coordinate bond, and this will have a structure of this way called as a ammonium ion. So it is one of the example for formation of ammonium ion which will explain us the coordinate bond. Second example we will go with a hydronium ion. Let us check with the second example for hydronium ion. Formation of hydronium ion. In this one, formation of hydronium ion, it also should have a same condition. That is, water molecule, oxygen atom is having two lone pair, hydrogen ion having a vacant orbital. It will loses its one electron to the vacant orbital of H plus ion, and it form a dative bond towards here and have a positive charge over oxygen, can be written as hydronium ion. Here it is a donor atom, it is acceptor, the bond is called as a coordinate covalent bond. But the very good example I want to explain about the SO2 molecule. That means check it here in the SO2 molecule. Directly I will tell you. Sulfur dioxide, sulfur having a 6 electron in the valence shell because it belongs to 6th group. Oxygen having a 6 electron in its valence shell because it belongs to 6th group. As well as according to the valence, according to electronic configuration, if you check it, oxygen atom is having only 6 electron in its valence shell. Now, oxygen atom is sharing this 2 electron, oxygen atom is taking this 2 electron from sulfur and completed its octet. At the same time, sulfur also take this 2 electron from oxygen and completed its octet. You can check it here, 2, 4 plus 2, 6 plus 2, 8. Oxygen, 2, 4, 6 plus 2, 8. They both completed its octet. If we are thinking that oxygen atom sharing its 2 electron from sulfur, here if it will share, suppose it is going to share this 2 electron from the sulfur, it will have 2, 4, 6 plus 2, oxygen completed its octet. What about at the same time, if the oxygen is sharing this 2 electron from sulfur, then sulfur has to share its 2 electron from oxygen. And by sharing this 2 electron from oxygen, sulfur will have 2, 4, 6, 8 plus 2, 10 electron in the valence shell. That is not possible, and that become unstable because it should have a octet configuration. In this case, what will happen here? Oxygen, this 2 electron I should write here, and you know, if you want to write the configuration of oxygen, it should be written in the form of 1s2, 2s2, 2p4, 4 plus 2, 6 plus 2, 8. You can check it here. In p orbital, it have px, py, pz. So still it is having a, what you can say, a 2, what you can say here, a 1 half field, and here one more half field is left with the oxygen. So in this case, oxygen atom has a tendency to take 2 electron from sulfur, and this sulfur will donate this 2 electron toward the oxygen. Now by sharing it will form the bond called as a covalent bond, and here sulfur donates its 2 electron to the oxygen, the bond called as a coordinate covalent bond. So this is the structure of SO2 molecule. In that one, we are having a covalent bond as well as a coordinate covalent bond. So these are the types of the chemical bonding we have seen: ionic bond, covalent bond, as well as the coordinate covalent bond or dative bond. Now check with the another examples. I want to give some few more examples for you, that is based on the octet rule. Or in this octet rule, whatever the structure of the molecule we have seen here, in that one some limitations are there. What is the limitations are there? We'll check it here. But before going to discuss the limitation, whatever I explain you, just take a short, we can say, summarize it all the thing. I explain you how to draw the structure of molecule. For drawing the structure of molecule, we should know how to draw the Lewis dot structure as well as how to know or what is the octet rule. Octet rule means having the 8 electron in its valence shell to get the stability, except 2, that is hydrogen and helium, which will have only duplet configuration, that is having a 2 electron in its valence shell. So some structures are there, they will not follow the octet rule, but then also these structures are stable, so that is come under the limitations. Now these are the limitations of octet rule. So what is the limitation of octet rule? The first one I want to explain you, that is about the structure of PCl5, and second one, that is the structure of SF6. You can check it here. By drawing the structure of PCl5, we have a same thing like that. It is either some kind of structure of PCl5 we are getting. Now check it here. One bond is equal to 2 electrons. So around the phosphorus, total number of bond how many? 5. That means around the phosphorus maximum number of electrons is how many? 10 electrons. That is not possible. And SF6, according to octet, SF6, 1, 2, 3, 4, 5 and 6. These are the 6 fluorine present around the sulfur. One bond equal to 2 electrons, 6 bond equal to how many? Maximum of 2 electrons. That means for octet rule, it should have how many? It should have a maximum of 8 electron units in the surrounding the central atom, or one of the atoms should be having a maximum of 8 electron to complete its octet. But here some molecules are there, like a PCl5 central atom is having more than 8 electron. In SF6 molecule, central atom sulfur is also having a more than 8 electron, that is a 2 electron. So these are the part come under the limitations of a octet rule. Now here where the limitations came, based on that some more theory came into existence, and whatever the another new theory came into existence to explain all these things, that will come a VBT, valence bond theory, VSEPR, another one is that hybridization. So in our my next class, where I am going to explain you about these all the three theories, that is a VBT, VSEPR and hybridization. Thank you my dear children, thank you very much.